Hello everyone, welcome back to Ansarkari. So we are taking up the next topic, which is related to monopoly, or we have dealt with the monopolistic competition also. So it is called the bilateral monopoly. Now, bilateral means monopoly of two people. So in this case, again, two people cannot be the sellers, two people cannot be the buyers. So in this case, we have single seller and a single buyer. So these are the two monopolist players. Now, single seller is called a monopolist, and a single buyer is known as monopsonist. So these are the terms related to this. For example, if we take a real life situation where we see a single seller and a single buyer can be, suppose there is a large trade union which is offering its labor services to, for example, a giant, we can say, corporate player who buys those labor services at a again fixed wage that would be determined. So this is one of the examples. Now when we're talking about the equilibrium price and output that would be determined, so we have seen that in case of monopolist, when we were dealing with the monopoly market, there is no unique supply curve of a monopoly. So how he or she, the player, will maximize the profit will depend upon how the monopoly chooses a point on the demand curve of the buyer, that is of the monopsonist, because monopoly is not having a supply curve of its own, because it is the only seller in the market, so it is having the absolute power to determine the price and the output. So because of the absence of a direct relationship or a defined relationship between the prices and the output that would be supplied, so it is maximized on the demand curve of the buyer. And in case of monopsonist, the single buyer, how this player will maximize the profit will depend upon choosing a point on the seller's supply function. So it is a supply function and not a curve, first of all. And monopsonist will not be having again a defined input demand function, because it is again the single buyer which is there in the market. So there is no again a definite input demand function that would be existing or functioning in a discrete sense, so that we can again get to know about how the relationship is being working between the prices and the output. So each player is choosing a point on others demand and the supply function, we can say. Now these two players are there. There are three possible scenarios when we go forward, how things will be working out between them. So first can be that both of them, they cooperate with each other and they achieve a Nash equilibrium. So this is the most ideal situation that they can be in when they are cooperating, and both would be again maximizing the joint profits. Another scenario would be that only one out of the two players will be dominating. So we can say either monopolist can dominate and other will have to follow the price and the output decision taken by the monopolist, and it can be vice versa also, that monopsonist can also dominate. So one of them dominates in taking the pricing and the output decision, that would be followed by the other. Third scenario can be that they do not cooperate with each other at all and the market breaks down. So the things, they do not function at all, and you can say no trade takes place between both the players. So we are moving from the best to the worst case scenario. So three possibilities are there. Now there are two approaches in determining the equilibrium, or again what is going to be the ultimate outcome when both the players are interacting with each other or trading. So one is again the normal approach that we have. So the first case we will see, so we'll have to draw a graph. So on y-axis we have price and the cost, which is plotted. On x-axis we have the output. So we have the demand curve of the monopsonist, who is the single buyer. So we label it, and this will also be the average revenue curve of the seller, that is the monopolist player. And correspondingly, we have the marginal revenue curve of, again, the seller. And apart from this, we draw the marginal expenditure and average expenditure curve. So this is the average expenditure curve of the buyer and correspondingly marginal expenditure curve of the buyer. So average expenditure curve is also same curve for the supply of the labor services and marginal cost of the seller. Now we will label it once we see how things will be functioning in this. So we see that the outcome of the working of this graph or the system between the bilateral monopolist will be that there is going to be indeterminate equilibrium would be there. Why we are using the word indeterminate is that we will get a range for equilibrium and no defined, we can say, wage rate would be achieved. So there would be an upper limit and lower limit that we will get out of this graph, and that is why things will be remaining indeterminate. Now how it will function, we'll see. For example, first we'll say that let's say the buyer, he feels that he or she is having full market power to set the price. Buyer, who's the monopsonist, full market power exists with the buyer to set the price and the output. So what will the buyer do? He will be equating the marginal expenditure with the marginal value of the product, and this marginal value would be given by the demand curve of the buyer that we have drawn. So you can see that the downward sloping this demand curve and intersection of marginal expenditure curve. So both of them are intersecting at, let's say, this point, which we can label as E1. Now when we extend the lines, we will get, this is the amount of labor, and this will be giving us the wage rate, equilibrium wage rate, let's say W1. So at E1 point, we'll see equilibrium wage would be OW1, and this would be the output at this level. So this is one possibility that will be an outcome of this. Another would be when, let's say, monopolist dominates the market, decides the price and the output. So in this case, we have seen under the monopoly market, marginal revenue equals the marginal cost in case of equilibrium. So here, if you see both these curves, so this is the marginal revenue curve of the seller. This we have seen is the marginal cost of the seller, which we have labeled also. And both of them are intersecting at this point. So this becomes the equilibrium when the monopolist dominates the market. So say this is point E2, and again we will get the labor or the output, and the price would be given by this point. So this is actually the wage rate. So here equilibrium wage would be this. This would be the equilibrium output or the amount of labor services that would be demanded. So at OL2 amount of labor, OW2 wages would be paid. So here we can clearly see that OW2 is greater than OW1, and this is actually the range. So this is the lower limit of the wage rate. This is the upper limit of the wage rate. So wage rate would be, it would be fluctuating between these two values. So we're not having again a defined value from where we started, that things remain indeterminate in the equilibrium. So there's a range bound movement. So this was the first approach, normally how we determine the equilibrium. Second approach is using the Edgeworth box. We are proving the same thing, that at equilibrium things are indeterminate. Edgeworth box approach. So we'll draw Edgeworth box and a graph correspondingly. So here we have quantity of money plotted on the y-axis, and on x-axis we have quantity of good X, which is there. This is the origin. Corresponding to this, we draw the indifference curves. So these are indifference curve of the buyer. Buyer is the monopsonist. So that is why we are labeling it with B, so that there's no confusion. B1, B2, B3. Now in case of indifference curve, the higher is the indifference curve, higher is the level of satisfaction that would be derived by the buyer. And at any point on the IC curve, the satisfaction remains the same. So these are, we can see, the properties of the indifference curve. And now we'll draw the Edgeworth box. So Edgeworth box, again, it's a box that remains closed. Here we have 2 points. We will explain this. There are two origins. So one is, in a way, you can see that this is one graph. So one origin would be this. This is another graph which is there. So another origin would be this. So we will label this. This is one origin. This is O dash, another origin. So it is representing two things. So here we will have quantity of good X. Here we have again the quantity of money plotted. So we will draw again the IC of both the players together in the Edgeworth box. So we will see that this one is S1, this one which is coming down, and this indifference curve is B1. So here we draw again, like for B1, if we have to draw more of ICs, so they will take this shape. We just have to draw in the upward direction because this graph is representing the things or how they will be functioning for the buyer. So if we started with B1, next would be B2, this is B3, and this is B4. You can see it is tangent to this S1 IC. Now these ICs are tangent to each other. So you can see S1. So this one would be S2. You can say, if you see from origin O dash at this particular level, because it is in a way a reverse drawing of the indifference curves for the seller, S1, S2. So for S1, these are the upward IC, we can say S3, S4. So they are tangent at all these points. So we are just drawing ones and then we'll explain. This is the contract curve. It is also known as the contract curve approach also. So we can label these points, let's say L, Q, R. Now we can say this is K point. Then we will understand its functioning by taking two more points. So this is point T, here we extended. This is E point, and one we take, let's say, point W. So correspondingly on this graph, this is point C, we will extend it on both the axes. M1 is the amount of money, this is good X, X2 amount, and M2 amount of money. So when we see the functioning, we have already like explained that b1, b2, b3, b4 are the indifference curve of the buyers convex to origin O. So if these are the shapes, we say that these graphs are convex to the origin O at this point. And correspondingly, we have drawn the ICs for the seller S1, S2, S3, and S4. These are convex to origin O dash. So in this case, greater is the indifference curve, the height, the level, greater is the satisfaction level of each player for whom we are, we are identifying or seeing the indifference curve. And OM, you can see this, okay, this total length is being represented as the total amount of money which is available with the buyer. So total money with buyer, or the monopsonist, we can say. So let's say if he ends up at point C, so it means we can say that the amount of money, so C point in this graph we are talking, so it would denote that OM1 is the amount of money that he has spent, or in a way it would be functioning in a reverse manner. M1 and M is this point, again the point that we have taken from here. So M1 is the amount of money being spent to acquire OX1 amount of good X by the buyer. Or we can say, in other words, that O dash N, this entire length, if we look at this, it would represent the maximum amount of good X that can be supplied by the monopolist. So monopolist is, since it is the single seller, so he is selling or making available this amount of total good X, and this would represent how much is being bought by the buyer. This is the total amount of money which is available. So that is why in this graph we have drawn a simplified version of again what is a single point would be denoting. So in the Edgeworth box, if we have a look, we see every point which is inside, any point that you draw inside the Edgeworth box will represent the trading point. So point inside will reflect the trading point between the buyer and the seller. And we have denoted that if, let's say, C is the point, what it will be denoting. So if inside the Edgeworth box we are starting from, let's say, point T, so in this case you will see that the buyer, it has taken OJ amount of good X. So since we have extended it from point T on the x-axis, this is the amount good X that has been acquired by the buyer, and he has spent OE money, or OE. This level is left. So he spent ME amount of money. Left with now only OE out of the total OM amount of money that he was having before. So that is the meaning. And for the monopolist, that is for the seller, he has sold the NH amount, that is again this amount and this amount. You can see the value is equal. So since he's a seller, so he has sold this much amount, that is why buyer has bought OJ amount. And the money that he has gained, we can say, is obtained again the ME amount, because buyer has spent this much amount of money. So this money goes to the seller. So these are, we can say, both the meanings or the interpretations that we can derive from point T inside the Edgeworth box. So if we join all these tangency points that we have already joined, we get the contract curve, and contract curve denotes all those points which are going to be advantageous to both the players, to the buyer and the seller. So these are denoting the maximum advantage, that is again the maximization of profits to each of the player, and they will be moving along only this contract curve. So if we see that when we look at the, let's say, the direction in the upside manner, like if we move in this direction, the ICs will be moving up for the buyer. So buyer would be at more benefit compared to the seller. And if we move in downward direction, the IC curves, these IC curves will be moving up. So seller would be at more advantage. So this is one, we can say, a concern, that both the players, they can again have a kind of a war on this particular aspect. So that is why we again say that range, it remains indeterminate. Now if we have a look at, let's say, point W, which is again, which is, you can say, away from the contract curve. This is the contract curve and W point is here. So it is denoting that the region, that is this particular region between QR, can see that if we draw ICs, they will be moving up for the buyer, and here for the seller also, inside only this region, the ICs for seller will also move up, you can see. So this becomes the most ideal place for both the players to be trading at only this particular section rather than at point W. So they will be coming back to this particular region only, and they will not trade at W, because they'll be more better off trading between or trading at this range of QR. So why only QR we are talking about? Because you can see these two ICs, they are more closest. Or if we take point W here also, so we say that which is better point, this intersection between these two ICs, or this region or the area which is being covered by the ICs. So this is the most ideal place to be at by both the players. So that's how we can say, again, through this also we get either this range, or we say the range of this contract curve. And now again, the players cannot be trading below point, say again, point L, because the player would be much better off at point M rather than being at any point below this IC curve of the buyer, because again, the player would be at a loss. So it would be better not to trade rather than take a trade in this particular region. So this is, we can say, in a way, the conclusion, and again the same that we have seen through the graphical method, that the under the equilibrium situation, things are indeterminate. We are only able to get the range of equilibrium wage and the output that can be better for both the players. So that's all in this particular video. Thank you so much for joining us on Ansarkari, and we'll be meeting with the next topic.